Welcome to another video. In this session, I want to find the integral coefficients of x cubed over 1 plus x raised to power 8. So this is integral calculus. It is integration by algebraic and trigonometric substitution. So there are some integral that if you want to deal with them due to substitution, you use algebraic substitution. There are some integral. If you want to deal with them, you use trigonometric substitution. There are some integral. If you want to deal with them, you agglutinate both algebraic and trigonometric substitution in order to get rid of them. So now the question goes thus: integrate x cubed over 1 plus x raised to power 8. So whenever we have to integrate this type of function, solution, then we are going to introduce an integral sign. So the integral, this is a sign of integral of x cubed over 1 plus x raised to power 8, the x. So when you see this type of integral, what comes to mind is how we are going to eliminate x and turn it to another variable. So we know that when you differentiate x raised to power 4, then the resulting function gives rise to power of 3, that is cubic function. So the cubic function will later eliminate this, leaving behind the substitution. So now we can say let u be equal to x raised to power 4. That is the substitution, the algebraic substitution we are going to use. So I can now rewrite this integral as x cubed over 1 plus x raised to power 4 all squared. So another way of writing 1 plus x raised to power 8, 1 plus x is 1 plus x raised to power 4 all squared. So let u be equal to x raised to power 4, then the x. So what I'm going to do now is not far-fetched. So I can now say the u, the x. I'm going to differentiate u with respect to x. So the u, the x is equal to 4x cubed. So if the u, the x is 4x cubed, what does that imply? If I make the x the subject of the situation, this implies that the x is equal to the u over 4x cubed. So what does that mean? It means that anywhere I see the x in my function, I'm going to replace that dx with the u all over 4x cubed. Now, I will now go back to the integral. I will now say that integral of x cubed over 1 plus x raised to power 4 all squared dx being equal to integral of x cubed over 1 plus. Now I have represented x raised to power 4 with u. So if I have done that, that means this expression becomes u 1 plus u all squared. So because my x raised to power 4 is ably represented as u, so it becomes 1 plus u all squared. Then my dx is now equal to the u all over what? All over 4x cubed, just like that. So what is the next line of action? S cubed cancels out s cubed. So we are left with integral of the u all over 1 plus u squared. So now, this has led us to another substitution. Interesting. It has led us to another substitution. Now, this type of integral, we are going to use trig substitution. Initially, we used algebraic substitution. And using algebraic substitution, we arrive at another form of integral, leading us to trig substitution. So the substitution I'm going to use here is let u be equal to tan theta. So if u is equal to tan theta, I'm going to differentiate u with respect to theta. So that implies that the u, the theta, is equal to the differential coefficient of tan theta is equal to sec squared theta. So what does that imply? If I do the cross multiplication, this implies that du is equal to sec squared theta or d theta. Now, what is left for me? I've represented u as sec squared theta. That means u will be written in terms of theta. So these one are the denominator, which is 1 plus u squared. 1 plus u squared will now be written as 1 plus, what is my u? From onset, my u was tan theta. So that is tan theta all squared. So this gives 1 plus tan squared theta. And recall from free identity that 1 plus tan squared theta is equal to sec squared theta. So if 1 plus tan squared theta is sec squared theta, so what does that imply? So that means my 1 plus u squared is now represented as what? Sec squared theta. So that implies that I will now go back to the integral. So that is the u all over. Now my 1 plus u squared, which is equal to 1 plus tan squared theta, which is in turn equal to sec squared theta, will now be equal to du over 1 plus u squared is equal to integral coefficient of, now my du was represented as sec squared theta d theta. So I have sec squared theta d theta over, now 1 plus u squared has been transformed to sec squared theta. So this eliminates this. So don't forget that here we are having du dx equal to 4x cubed. So such that dx is du all over 4x cubed. So this 4 here comes out of the integral, becomes 1 over 4. So don't let us forget. So this becomes 1 over 4 because here we are left with a constant which is 4. So I can just put that here. Yes, good. Let's put that here. Let's include. So that 1 over 4 appears here. So that implies it appears here because our dx is du all over 4x cubed. So 1 over dx is du over 4x cubed. So I'm representing dx to be du all over 4x cubed. So that 1 over 4 comes out of that integral. So I will now be left with integral 1 over 4 integral coefficient of d theta. So the next line of action now is to integrate this function d theta. So 1 over 4 integral coefficient of d theta is equal to 1 over 4 theta plus arbitrary constant. So now if the integral, the result is 1 over 4 theta plus arbitrary constant, and from Adam our u is equal to tan theta, because I must write my final answer in terms of x. Now I went from x to u, then u back to theta. Now since my final answer is in terms of theta, I will now go back from theta back to u, then back to x. So that implies that this will now be now, since u is equal to tan theta. So what does that imply? This implies that theta is equal to arctan of u. So from here, theta will be tan inverse of u. So I can rewrite this as 1 over 4 theta plus arbitrary constant is equal to 1 over 4. Now my theta is now what? Arctan of variable u plus c. Now we are not done yet. My u, again, from Adam, my u was represented as what? X raised to power 4. Because my answer must be in terms of x. We are integrating with respect to x. So this result again becomes 1/4 arctan of u plus arbitrary constant being equal to 1 over 4 arctan of, then my u from onset was what? X raised to power 4. So 1 over 4 tan inverse of x raised to power 4 plus arbitrary constant. So that is the result of the integral. And one funny thing about integration is that you can just try it on your own, that any function you integrate and get your result. If you want to check whether you are right or wrong, if you differentiate that answer, it gives you back the question. So that is the end of today's video. So don't forget to like my channel, don't forget to subscribe, don't forget to comment and all of that. So that is the end of the session. So life is always continuous, life is differentiable, life is integrable, but not Lebesgue measuring. It is a diet.